Okay, now that we understand how lists work in Python, we should talk about other data collections. There are three in particular that I want you to know about. Those are tuples, sets, and dictionaries. They all have some similarities, but also subtle differences to lists. So it's important that we understand what sort of operations and methods can apply to them, how we create them, and how we can develop Python code that uses them. So let's start with tuples, or tuple, depending on how you prefer to pronounce it. So a tuple is like a list, except that tuples are immutable. So that means they can't be changed. The other key feature is that they're identified by parentheses as opposed to square brackets. So for example, here would be a tuple called dimensions that contains three numbers, 19, 20, 10, 80, and 3. You might imagine this could be the dimensions of a color image. So we've got the height and the width and then the RGB, indicated by the three layers there. An important idea here is that we can index a tuple like we would a list. So in this case, the first element at index 0 is 1920. We can also slice them like we would lists, but we can't change them. So if I try and reassign the value 1 to dimensions at 2, what I'm trying to do is to replace the 3 here with a 1. So the question is, can we do that? And the answer is no. This is the error that we would receive. Here are the operations that can apply to tuples. I actually want to pull up a Python shell to demonstrate each of these now. Here's our Python shell. Let's go ahead and create a tuple. Remember I said that we can do that by having parentheses instead of square brackets. So this would be a tuple with the values 1 and 2. And to prove that it's a tuple, I'll simply use the type function. You can see the class given here. Now, if I wanted to do concatenation, that's like addition. So let's try and add. Ooh, that didn't work. Let's try, there we go. So I guess it has trouble with a tuple with only one element. It thinks that you're doing literal addition with an integer. But if I wanted to take x, which had 1 and 2, and then concatenate 3 and 4 to it, I would add. If I want to repeat a tuple, I can multiply it. So when I multiply it by 3, you'll notice that it repeated the 1s and 2s 3 times, just like we would with a list. We already saw indexing, we already saw slicing. We can also get the length of a tuple. So the length of x by itself is 2, but if we were to repeat that tuple 10 times, now the length should be 20, right? And that's because there are the 20 items in that particular tuple. We can iterate over a tuple by using a for loop. So let's create another tuple here called y, and let's just do the numbers 2, 2, 8, and 0, right? There's our tuple. And now I can say something like, for value in y, I'm going to iterate over each of those values in y, and then instead of just printing the value, let's add 1 to the value. So we'll print the value plus 1. Look at what happened there, 3, 3, 9, 1, each on separate lines, because each of them became the value, of that variable called value in turn, and then we added 1. So we added 1 to the 2, we added 1 to the 2, we added 1 to the 8, and 1 to the 0. We can also use membership. So if I wanted to, let's say that I had a tuple with professors. If I wanted to know if somebody was in that list, right? So for instance, is Dr. Martin, President Martin, is he in the list of professors here? No, he's not. Okay, he'd probably be in the list of presidents. But Roberson, is he in there? True. Yes. So we use the word in to determine membership, to ask, is it true or false that something is a member of the tuple? Okay, so note, all of those operations, they're identical to lists. The only difference there was that we were dealing with parentheses instead of square brackets for the list itself. Tuples also have methods. Okay, methods are functions that can apply directly to the tuple. This is a much shorter list than we saw for list methods. Let's try each of these out in turn. So the index method allows us to take a tuple, like the one that we see here, and find the index of a particular instance or item in the tuple. So if I wanted to know where is Burke in professors, he's at index 1 because we start counting from 0. If I were to ask where Cazalas is in professors, you'll notice it gets an error because that value is not a part of the tuple. We could also do that for, let's make a tuple 1, 2, 3, 4, 5, 4, 3, 2, 1. And if we were to index the value 3, notice 3 is in this tuple 2 different times. Which one is it going to return? It should return the first instance. So the first instance of a 3 is at index 2. If I were to, let's say I was to slice that from index 3 onward, now where will the index of the value 3 be if I'm only looking at the third index on? So if index 0 now in this slice is going to be the 4, we'll see 4, 5, 4, 3. I think this result should show 3. And it does. What if we wanted to do the count? So we wanted to see how many times does a certain item exist in the tuple. The dot count method will show us in this case that it's in there 2 times. If we had, let's create another tuple of just 1s and 0s. Maybe this is keeping track of like wins and losses of your favorite sporting team. So we've got a bunch of 1s and 0s there. If I wanted to know how many times did 0 show up, I do x.count 0, and you'd see that there were 7 zeros while there were 14 1s, which means the length of x, considering it's only 0s and 1s, should be 21, because that's 7 plus 14. These operations are identical to those for lists, but it's much smaller of a subset. Speaking of sets, a set is another type of data collection that's also like a list, except for 2 key features. Number 1, sets are unordered and unindexed. That means that there is no sense of what's at index 0 versus index 1 or 2 or 3. It's just a collection of things that are unordered, unindexed. What differentiates them syntactically is that they're identified by curly brackets instead of our square brackets. So for example, if I created a variable x and I assigned to x 2280, notice I've used square brackets. That would be a list. So these things are ordered and they're indexable. If I then create a set of that list x, look at what it shows. It now shows in curly brackets the numbers 8, 0, and 2. Now the order of that really doesn't matter. Like, why did it do 8 before 0? Why not 0 to 8? We actually don't know. There's some underlying algorithm that determines exactly how they're going to be displayed, but the beauty of sets is that it actually doesn't matter about how they're ordered. It just matters whether a value is in there. You'll also notice that the 2 did not get duplicated, right? So the idea of a set is that we can't have duplicates. It's a nice way to, for instance, I could look at all of the grades of students in this class, and if I were to do the set of those grades, presumably I would see all the different letter grades that the students got, but I wouldn't see duplicates. So I wouldn't need to know that there were 10 A's and 12 B's and however many C's, hopefully no D's or F's. I would just see A, B, C, maybe not even in that order. Now we can assign a set to a variable like S in this case, but can we index S? No, we can't. Here's the error that you would get. We can also create a set directly by applying it to a list like 2290. If we were then to look at the length of y, it's not going to be 4, even though there are 4 numbers there. It's going to be 3 because there are 3 unique numbers. Now, if I were to do this special character here, an and, this is kind of new. So print s and y. Let's see what that comes up with. 0 and 2. So let's think about what S is. So S is going to be 8, 0, and 2. And then presumably Y, based on the numbers we provided, 2, 2, 9, and 0, I think that'll be like a 2, a 9, and a 0. And remember here, the order doesn't matter. So what happened here with the and, the ampersand operator? Well, can you tell that it identified the common elements? So 0 and 2 are in S. 0 and 2 are in Y. 8 and 9, those only exist in one of those 2 sets. This is why we call the ampersand operation an intersection. So one way to think of this is like with a Venn diagram. So you can see that the intersection is all of the values that existed in both of them. It's where the Venn diagram here overlaps. Now, if we can find the intersection, presumably we can find other features about this Venn diagram. Let's try that out. What about this vertical pipe or like vertical line? Try and find that on your keyboard. If your keyboard's like mine, you probably have to hit the shift key to get to it. What does this do? Well, it prints 0, 2, 8, and 9. 0, 2, 8, and 9. Now that's interesting. Let's look over at the Venn diagram. What is 0, 2, 8, and 9? Well, that turns out to be quite literally everything that's involved in either of these two sets. We would call that the union of the two sets. So here we go. Here are the operations. We can get the length just like we could for lists and tuples. We can iterate over them just like we could for lists and tuples. We can do membership using the in keyword, right? And those are going to be the same as lists and tuples. The bottom four are a little bit different. And note, this isn't an exhaustive list. You can look at online documentation, such as the link provided here, to see some of the other things that you can do with sets. But these four, I think, are interesting because, so union and intersection, we already saw that. Let's do the difference as well. Let me pull up a shell again. So here is our shell. I'll create two sets. Let's do, tell you what, let's do 2280 again for set A, and then set B is going to be 2290. I'm just using the course codes for our CS courses. Let's look at those two sets. You can see where they're similar, where they're different. We could also apply the type function to them just to verify that they are indeed sets. The curly brackets identify that to us visually. Now, we already did the intersection of A and B. That's the common elements. The union of the two is all of the elements together. What about the difference? So A minus B, that's just the 8. So that's saying what are the things, the elements that are in A, but not in B? What about B minus A? Will this also give us 8? Pause the video to see if you can answer that for yourself. Did you get it? Turns out it's going to be different. This will be 9. So this refers to all of the elements that are in B, but not in A. And if we were to do the symmetric difference, which is like that caret symbol, for me that's shift 6, notice that that gives us 9 and 8. And if we swap the order of those variables, it doesn't matter. It's still, now it's listed as 8 and 9, but remember, in sets, order doesn't matter. And you also can't index them. We can't say what is at index 0 of the set. We just care about elements being in the set or not. So we can say something like this. Is 0 in A? Yes, it is. Is 9 in A? No, it's not. So the last type of data collection is perhaps the most interesting for Python programmers, and that's something called a dictionary. Note that it's not as common in other languages. You might hear some similar data structures, like a hash map, perhaps in Java. But dictionaries are really powerful, and here's how they work. So lists, in general, if you recall, they involve sequential data. So you access items in the list by the index. The index is the position in the sequence. So the first item in the sequence is at index 0. The last item is at index -1, if we didn't know how long the list was. A dictionary involves non-sequential data. So instead of using an index to look up a position, we're going to use something called a key-value pair. So this might be easier to understand if I give you an example. Suppose we need to keep track of phone numbers in some Python program. And maybe we've got my office phone number. Perhaps you've got Dr. Roberson's phone number. I might be dating myself now with Jenny 8675309. Perhaps you're too young to understand that reference. Look it up. And then Prince, maybe that's Prince's phone number 7779311. So you could use a list, technically, right? And here's what that list might look like. I can say numbers equals, and then in square brackets, I provide a string of each of these phone numbers. But here's the problem. You would need to memorize which index corresponds to which person. Like, how do I know whose number is at index 3? In this particular case, I could just look at my bullet points and say, well, that's Prince at index 3. That's the 4th number. But suppose I had numbers for everyone at Florida Southern. That would be thousands of numbers. How in the world will I know who's at index 1387? I won't. So a dictionary makes this easier by using key value pairs. We access the values, so in this case that would be the phone numbers, associated with a particular key. So in this case that would be the name of the person. A collection that allows us to look up information associated with arbitrary keys, we call this a mapping. And that's why in other languages you might hear something like a hash map or an associative array. There are many practical examples of where this could apply. So usernames and passwords is another one. State names and capitals. We could have used this on our first project for the weather app by having the state name mapping to an abbreviation. We could also map student IDs to grades, and so on and so forth. A lot of practical uses for dictionaries. So how do you create a Python dictionary? First thing you need to remember is that we use curly braces or curly brackets. And we're going to put key value pairs in those brackets. That's the easiest way, kind of the standard way. We join the pairs by a colon, and we separate them by a comma. So for example, in the phone number illustration that I gave, you will notice that I've got curly brackets around numbers. Instead of, like in a list, we'd use square brackets. I've got colons separating each of the key value pairs, and then I have commas separating each of the items, right? So look at the first key value pair. So the key is Dr. Eicholtz. The value associated with Dr. Eicholtz is my phone number. How do we index a Python dictionary? Well, we simply use the key. So if I want to know Dr. Eicholtz's phone number, instead of memorizing some index for that, I just say numbers at Dr. Eicholtz. We could not do this with a list. With a list, we would need to provide an integer index value in the square brackets. But I should point out that we still use square brackets to index the dictionary, even though the dictionary was created with curly brackets. So the general form here is that we have the dictionary variable, and then in the square brackets we put the key. This is very similar to indexing for a list or a tuple. Some important notes. Mappings are inherently unordered. There is no sense of like what comes first or what comes last. Internally, Python's going to store those dictionaries in a way that makes the lookup very efficient. When the dictionary is printed, the order of keys may appear random, but it truly isn't. If you wanted to keep a collection in a certain order, you would need to use a sequence like a list, rather than a mapping. And then the keys can be any immutable type. So keys could actually be numbers. They could be integer values, in which case the indexing would all of a sudden look very similar to a list, except those don't have to be sequential integer values. But keys can be any immutable type. Values can be any data type, including programmer-defined stuff like what you'll learn in OOP, object-oriented programming. So next we have some dictionary operations. Here is the table. If you wanted to figure out membership in terms of the keys, you use that keyword in. So we say, is a key in a dictionary? That will return true or false. It's a Boolean. If you wanted to get a list of the keys, do dot keys. If you wanted a list of the values, you do dot values. If you wanted the key value pairs, well, because those need to be ordered, where the key is first and the value second, it makes sense that the output for that method, dot items, is a tuple, right? So it's a list of tuples. Each item in the list is a tuple of length 2, where the first index is the key and the second is the value. We can delete a specific key from the dictionary using the del command. That one's kind of odd because most functions that we apply require parentheses, but this one doesn't. If we wanted to empty all of the entries or delete them all, we simply do the name of the dictionary dot clear. We could loop over the keys. You can technically loop over the key value pairs as well. Or we can get a particular value from the dictionary using a key with a default value if that key doesn't exist. Let's try this out with a simple example. Okay, I've created a dictionary. The keys here are integer values. Maybe those are like ID numbers, and perhaps the strings that are provided as the value to each of the keys. Maybe that's like a passcode of some kind. So if we look at the dictionary, right, we can see in the curly brackets each of those key value pairs. If I wanted to check if a certain key, like 11111, is in the dictionary, I do that, use the in keyword. That is true. If I checked one that wasn't there, it would give me a false. If I wanted to look at all the keys as a list, I do .keys. Well, actually, so technically that's not a list. I would need to convert it to a list. There you go. And now I can index various things or do some slicing, like say, give me the first two. I can also get the values. And if I wanted that to be officially a list, I can just apply the list function to it. So there are all of the passcodes for my different user IDs. If I wanted the items, make sure I get the parentheses when I do a method. So if I do a list of those items, now you can see a list of tuples, right? So why don't I call this items? And now watch what happens when I do items. If I wanted to know who is the last user ID in this list, I do items -1, and there's the user ID at index 0 and the corresponding passcode at index 1. If I wanted to delete a specific item from this dictionary, I could say, let's delete the key 54321. And now when I look at D, you'll see that there are only 3 users here now, and 54321 is gone. If I wanted to delete all of them, I could do d.clear, and now D is just an empty dictionary. Right? The length of D is 0. Let's go back up and reset our dictionary. Okay, because now we can do the get method. So if I want to get the value for a particular item, this is similar to indexing, right? That gives me the same thing as if I did this. But the problem is that if I type a number that doesn't exist, when I do indexing, it will give me an error. If I use the get command, and I have a default value, then if that key doesn't exist, it will give me the default value. If the key does exist, it will give me the corresponding value to that key. Those are the main dictionary operations. Now it turns out that much like lists, dictionaries also have the ability to do comprehensions, a dictionary comprehension. It's a little bit beyond the scope of this class, but I'd encourage you to look into that in the documentation or having a conversation with AI, because dictionaries, again, are kind of a powerful tool in addition to lists for any Python programmer. Thanks so much for watching.